If you can dream it, we can help you create it. Welcome to the You Create podcast, the show that teaches you how to take the power and flexibility of a Stepcraft 3D CNC system and turn your ideas into reality. So let your ideas flow, because we want to know, what will you create?
Okay, everybody, welcome back to the You Create podcast. This is episode 10. My name is Eric, and I am your host here. I want to wish everybody a happy new year, as today is Saturday, January 2nd, and I'm happy to be back here recording for you. It's been a very busy couple of weeks here at Stepcraft, and it's been hard for me to get back to the mic, but I've got a ton of stuff that came up from hundreds of different conversations I've had with people that I want to get together and start putting some shows together here and getting this information out on the podcast. So, all right, so the first thing I want to talk about here is model railroading. One of our users and listeners of the podcast and a fellow Stepcraft owner had told me about the Railroad Hobby Show, which is railroadhobbyshow.com. It's located in West Springfield, Massachusetts, coming up on January 30th and 31st. Now, I've been to a couple of model railroad shows locally here where I live, and you go in and it's in like a basketball stadium, not stadium, but like a gym, in a gymnasium, that type of thing, about that size. And I thought about it and I said, well, maybe it's worth going and having a little tabletop set up there to show Stepcraft to model railroaders. In Germany, that's kind of where Stepcraft got started, was in the model railroading industry. So here in the U.S., I would think that the radio control industry, as far as hobbyists are concerned, would be much greater of a potential for people to be interested in using a home-based CNC machine. But in Europe, its model railroading is massive, and that's where they got their start. So I took a look at this show, and I talked to some of the folks there, and turns out that it's not what I thought. It's actually touted as the largest model railroad show in the country, and from looking at who's exhibiting and the space that they have at this convention center, and just comments that people put online about the fact that they can't see the whole show in one day, kind of blew my mind. So we are going to be exhibiting there. We have a 10 by 10 booth. I don't know the number yet, but if you're listening and you're in the Massachusetts area and you love model railroading, or you have kids that, it just might make a great afternoon with your kids to see some of the amazing model railroad exhibits that they have. And we're hoping that we can expose Stepcraft to the U.S.-based model railroading market. And I'm excited about this show. I've never done a model railroad show before. I've done hundreds of radio control hobby shows, both with when I was with RC Universe and with the magazines, and I'm excited to try something new. So that's going to be, again, January 30th and 31st of 2016, and the website is railroadhobbyshow.com, and I will put a link to that in the show notes. And it's coming up quick, and really excited. New Year's here, and I want to get out in front of as many people as I possibly can in different markets for Stepcraft. I love talking to people about CNC and our machines and things you can build, and seeing ideas that other people have. And I think that this is going to be a pretty awesome weekend for us. So I'm looking forward to that, and hoping that we will see some fellow Stepcraft owners there, or people who are interested in what we have to offer. So anyway, that's wanted to start off by talking about that. And if any of the listeners that are out there have used CNC with model railroading, I would love to hear from you. And if you could email me at info@stepcraft.us, that would be awesome. I'd love to see some examples of some things that you've made. I could use photos and project photos of different CNC related items as they pertain to model railroad for this show. So that would be awesome if you wouldn't mind sharing that with me. So thank you very much for that in advance. Okay, so I want to get into a little bit of technical talk here for this episode. This is a common question that we get all the time, specifically from beginners and maybe some people who've been using CNC for a while. We'll touch on some things that maybe you haven't thought about here, but it's really pertaining to how to zero up your job. Now, typically when we talk about zeroing a job, we talk in terms of XY zero. When you put your workpiece on the machine and you fixture it down, you've got a zero position that's established for both the X and Y axis that'll be the starting position for your job. Now, a common place to set up an XY0 for a job is the lower left corner, or closest to you left corner, or bottom left, I guess you could say. And that seems to be, it's defaulted. We're going to talk a lot about the Vectric software here and how to do certain things with Vectric because that's what we sell and support. But the same thing will apply to any CAM software that you have. But on Vectric software, when you open up a job, they typically defaults to the lower left, which is where a lot of people will keep that 0 point. Now, there are other choices that you can make as far as a zero position when you're setting up your job. And it really just depends on the workpiece and the type of job that you're doing. You could set it up for the upper left, upper right, lower right, or center. And again, it really depends on the job that you're doing. Now, my buddy Bill Griggs, who runs the CNC Router Tips podcast, also has a company called The Maker's Guide, and he sells a triple edge finder device, which it's a pretty ingenious device. You put it on the edge of your workpiece, and you can use it to touch off the X and Y so that you can get your tool exactly to the bottom corner of a piece when you're setting up your job. And I've not used it. I've watched all the video. I've talked to him about it. The reason that I haven't used it is because the software macro that they have for it works with Mach 3. And in order for us to use it with a Stepcraft, we would have to make a macro for UCCNC, which we haven't had a chance to do yet. So I'm hoping that we will be able to entertain doing that so that we could offer to resell or at least send people to Bill's site to buy that triple edge finder, because for certain types of jobs, it's a pretty ingenious tool. Especially if you're working on a job that is, say you're running a plate of aluminum and it's a square piece that you're going to cut out of that aluminum. Well, it doesn't make sense to start your XY0 in the middle of the plate or off the edge where you've got to actually machine out all four sides. If the bottom left corner is a 90 degree, then you might as well take advantage of the edge of the plate that you're putting in your CNC machine. So why make the machine cut all four sides when you can just cut two and use the factory edges for that? So in a case like that, it would really, this tool is very, very helpful to establish your XY0 in the lower left corner of the workpiece so that you can run your job. Of course, it really depends on you making sure that the plate is perpendicular to both the X and Y axis. If it's skewed at all, then when the machine goes to run the edges, it's going to actually cut into the metal or cut into air, and you're not going to end up with the part the way you want. But we're assuming that you fixtured it square to the machine and that you're going to try to establish your XY0 for that part. Now that's a pretty standard thing when you're using aluminum or plastics or things like that, where you want to incorporate the edges, the factory edges of the material. Then you're going to want to be able to touch off on X and Y for the edge. Now, the way you can do it without a device like the triple edge finder is you can lower your Z height so that it's just above the bed of the table, and you're going to want to move it to the left of the material that you're working on. And then what you're going to do is you're going to slowly move the x-axis to the right so that the tool is moving close to the edge of the part. And what you're going to do is you're going to want to touch off the tool to the edge. And the easiest way to do that is to use a piece of paper and put it on the edge of the material so that as you slowly move the tool towards the edge, you'll feel the paper pinch. Like you won't be able to move it as much. You'll feel a pinch there. When that happens, then you go ahead and you zero your x-axis. So now you know that your x0 is on the left edge of your workpiece. Then you're going to move the gantry to below the bottom edge of the workpiece. So you're going to move the y-axis down, and you're going to do the same thing. You're going to use a piece of paper, except this time you're going to move the the y-axis towards the edge of the bottom of the piece using a piece of paper until it touches off. And once it does, you're going to zero the y-axis. So now if you were to go to home, you would be in the lower left corner, and the edge of your tool will be even with the lower edge and the left edge of the workpiece. And at that point, you've now established that lower corner is your XY0. I know this sounds complicated, but there are a lot of times where you're going to want to use a piece of material that you're going to want to establish that location. And aluminum is one that I tend to do that with a lot, because I don't like having to stress the machine out by cutting places that I don't need to. If I can utilize a factory edge, then I do it. Especially if we're working with block material where it's thicker and you've got to mill deep, it just makes a lot of extra work for the tool to try to cut it out from the middle of a block. Now, when it comes to cutting wood's a little bit different. It's a lot of times, depending on the piece of wood that you're using, if your edges aren't perfectly square, plus it's wood, it's easier to cut. A lot of times what I'll do with a piece of wood, I'll establish a lower left XY0 location, but I'll usually move the tool in 1/8 of an inch from the bottom and from the left edge and establish that as 0. And then I'm cutting, so that way I'm cutting a clean cut all the way around the part when I do my final profile cutout for that part. So that's typically what I do with regards to wood when I'm using a lower left XY0, especially if it's like birch plywood or something like that, where it's not super critical to utilize the factory edges, and I want to make sure that all 4 edges are machined from the CNC. So then I utilize that. Now, there are times where you'd want to use a center 0 position. And I'll give you a couple of examples. I have a customer who creates these name blocks. It's basically a block of wood about 8 inches wide by 3 inches tall, about 1.5 inches deep. And what he does is he sells them online and has the people, he customizes them. So he'll put a person's name, which is V-carved, into the face of it. So what he did was he went ahead and made these blocks on the CNC with rounded edges, and he made like 25 of them all at one time. And then he went and he clear coated them, sanded them, got them all set, and they're sitting there. Those are blanks. So when he gets an order, he takes the blank and he loads it into a fixture that he made on the machine. So basically, the fixture was a piece of wood with a cutout in it that's exactly the same size as the block. So the block fits into the piece of wood snugly, it doesn't move, and he squares that off to his CNC. And what he did was, on all of the blocks, he measured the center point by measuring across and up and down. And that's where he sets up all his jobs. So he'll go into Vectric V-Carve and he'll type in the person's name, say it's Nancy. And so he'll type that in. But his 0 point for that job is now the center instead of the left, the lower left. So when he takes the tool and he moves it over to the center point that he made on the block, and he zeroes the job there, now when he goes to V-carve that name into the block, it's going to be perfectly centered within that block, because that's what he used for a starting point. Now, he couldn't use a lower left XY0, because all the corners on the block were rounded. So essentially there wasn't really a square corner for him to zero off against. So in that case, using the center was the right choice. That was the easiest way to do it. And he set it up so it's a very, very quick process. Take the block out, put the next one in, type the name into VCarve. It's automatically centered on the block, the job that he made, and he's good to go. Then he quickly VCarves it. Because the blocks were already clear coated, all he has to do once it's VCarved is paint the letters on the inside, give it a light sanding on the surface that removes the excess paint from the top, and then he clears it again, and you have a perfect name block with a VCarve name the letters are all black and the surface is clear wood. So that's one example of utilizing a machine like this for a production type environment where you're making things that are personalized for people, and being able to use that XY center is very helpful in that situation. Now, there are some cases where I used a lower right edge to touch off, and I'll give you an example for that. So say you have a piece of material that's 12 by 12 square, and you mount that on your CNC, and now you have two jobs that you're going to run. They're identical. So both things are identical. They're 6 inches tall by, say, 5 inches wide. Now, the difference between the two is that the name is personalized on each one. So you have two ways of doing that. You could basically modify your file to make the file twice as wide, copy the work piece over next to it, and then customize the name on each one, and then run it on the 12 by 12 piece of material as one continuous job. Now, that's one way to do it. However, a lot of people, when they're setting up to make custom things that are going to kind of be mass produced or produced on demand, the reason I wouldn't do it that way is because suppose I get 3 orders, right? So now I've got a file that's 2 up. So that's good for the first 2. But then when I go to do the third, I don't have a second one on the right side. So in a case like that, I would use one master file that's a 1-up job. And all I would do is I would customize the name. And on the first job, I would set it for the lower left corner, and I would touch off the material on the lower left when I set up the CNC, and then I would run the job. Now the job is going to work from the left of the piece towards the center. Now, once that's done, I'll go back into VCarve, I'll change the name, and I will reestablish the home position to the lower right. And then I recalculate the toolpaths, output the file. This time before I run the job, I touch off the tool to the lower right corner. So what's going to happen now is that job is going to start on the lower right-hand corner and kind of work to the left. So everything is going to shift from the left. So it won't go any further right than where that established lower right corner is. And what that's going to do is because I already fixtured the material, it's basically going to let me, work from that side. So I'm minimizing waste. Now, I suppose the other way to do it is I could re-zero the part to the edge of the material where the first piece was cut out. But just, for a simple start point for XY0 is just to retouch off on the other corner. If you're going to touch off the tool anyway, you might as well touch it off to the edge of the workpiece. And, that's just another way to do it. And so that's a case where I would need to use a lower right as a starting point, which essentially in Vectric, it's called as XY datum, and it's just the starting location for where you're going to establish your job. Now, another case where I would use the center point is, say I have a piece of material and I need to cut a hole in it. And maybe the hole I want to cut is 1 3/4 inches in diameter. So it's bigger than something I would have a drill bit for that I could use a drill press. Well, this is a perfect, simple little case where a CNC comes in amazingly handy for that. What I'll do is I'll mark off on the workpiece where I want the center of the circle to be. Then I go into a program like Cut2D. It doesn't need to be anything fancy. And I establish a work size piece, say 2 inches square. I'm going to go a little bit bigger than the diameter of the circle. I'm going to set the 0 datum to the middle of the part. And then I'm going to create a circle that's 1 3/4 inches in diameter. And I'm going to center it on the part. So it's centered within that circle. I'm going to select this circle. I'm going to go to the toolpath, and I'm going to create a profile toolpath, cutting on the inside of the line. And I'm going to set my depth and select whatever end mill I want to use for that particular job. It doesn't really matter the diameter because you're cutting to the inside of the line anyway. It's just a matter of how much material you're removing in those passes. Then I'm going to load the piece of material onto my CNC. I'm going to fixture it down, and I'm going to move the tool over and to the center point that I just drew the mark for. And when I run the job from there, I'm going to end up with my 1 3/4 circle exactly where I wanted it on the part. So it's a case where you can use a CNC. It doesn't necessarily, you're not necessarily CNC in a whole part, but there might be something that you're working on that, geez, I wish I could put a square hole, say. Maybe you're making a light box or something, and you want to put a switch that you bought from Radio Shack in there as a power switch, and the switch is square. That's just as easy. Measure a 0 point where the center is going to be, and then go into Cut 2D, draw the square, create an inside profile toolpath for it, mount the material, cut it out. You have a perfect square in that material to mount your tool. So, that's one of the things with CNC. You don't always have to think of doing the entire job. It's not always a big carving job or cutting job. A CNC could be used as simply as a drill, like in place of a drill press or something like that. It's just a very quick way to get a precise cutout or hole or something that you need in a part or a piece of work that you're working on. So that's one of the benefits of utilizing a center point, and why you would use the different start points on your job. Now, it's very important that you never reset the XY start point on especially on a multi-tool job. So for instance, say you're doing a carving job and you got to use 3 different end mills. Maybe you're using a 1/4 inch roughing, an 1/8 inch ball nose, and then switching to a 1/16 inch ball nose for the fine detail work. Well, in that job, you've got your initial tool plus 2 additional tool changes. And every time you change the tool, you're going to have to reestablish the Z height, which I'll talk about in a minute. But once you do that, you don't want to move the original XY starting point. If you do that, then you'll never have a chance of the next tool path aligning with the previous tool path, and you'll ruin the job. So, especially on CNC, you can zero off each coordinate independently, but you want to make very sure that you don't accidentally click the zero all button when the tool is in a different spot other than the starting point 0. So that's just something to be careful of. You don't ever want to move that XY coordinate when you're doing a multi-tool job. Now, part of a multi-tool job is going to be part of any job actually is setting the Z height. Now, when you load a tool in, we already talked about how you touch off X and Y if you're trying to find the edge, and how you got to establish that coordinate first. But then you have to touch off the machine has to know that the tool has made contact with the surface of the machine. Now, you have 2 choices when you're setting up the program. You can set it up to touch off against the surface of the machine or the bed of the machine or the top of the workpiece that you're working on. Majority of the time, you're going to touch off on the top of the workpiece. There are some cases where I like to touch off on the bed. For instance, if I'm milling a piece of aluminum that's 1/8 of an inch thick, I will touch off on the bed if I have the aluminum clamped down to my T-slot table, and I'll tell the program that I want to go down 0.125 inches, and I know that it's going to cut right through but not going to mar the surface of the T-slot table. At least that's on our machine. I know the accuracy of it, so I know that I can do that with confidence and not have to worry about using a spoil board. You'll also use the bed when you're using tools like a drag knife or a plotting pen or something like that. You're going to use the bed as your starting Z height. So, but if you're working on wood or other materials, you want to touch off the Z on the top surface of the material. And it's basically the same process as doing the X and Y. You're going to lower the tool tip. I use a piece of paper. Keep lowering it very slowly until you can feel like you're moving the paper, and all of a sudden you can feel that the paper is being pinched by the tool. At that point, set your Z0 and you're good to go. Now, your accuracy on the Z is going to be, plus or minus a couple thousandths or whatever the thickness of the paper is. Now, for most wood jobs, that's probably more than fine. If you need more of an accuracy, or you just find that changing tools for a multi-tool job and touching it off manually is a pain in the neck, you can invest in a tool length sensor. We have one for Stepcraft. I know a lot of CNC machines have them, and I know there's some DIY ones out there that people have made. And basically all our touch-off sensor, how it works, it's a machine piece of aluminum with a button in the middle and has a cable on it. It's wired into the machine. You place this touch-off sensor on the top surface of the material you're working on, and you place it right under the end mill. Then on UCCNC, there's a touch-off button, and you click that button, and the end mill slowly lowers until it touches and pushes the button down. As soon as the button makes contact, it quickly retracts up. Take the tool length sensor out of the way, and if you do go to zero, you'll find that tool is exactly on the top surface of the machine. And basically how that works is that the macro for the tool touch-off sensor has been preset for the height of the sensor itself. So we knew ahead of time exactly how high that tool sensor was when the button was pressed. So we put that in there, and when it touches it off, it automatically takes into consideration the height of the sensor and subtracts that from where the tool is, and now you've got your zeros right on the top of the machine. It's available for Stepcraft. I know a lot of other machines have it too. If you're going to do jobs that are going to require multiple tool changes, then by all means, I recommend that you get it, because it just makes the process a lot easier and more accurate. It's accurate every time. And, that's important when you're working on jobs, especially jobs that are, like a more precise material, like maybe aluminum or brass or something like that. Now, one thing I want to talk about with regards to multiple tool jobs is we are getting ready to release what is kind of an industry first in this space, and meaning in this personal CNC, this price point range, and that's an automatic tool changer. Now, automatic tool changers have been around forever. They're the larger machines. When you get into industrial machines, most of them have them as an option, or they have them integrated. Because you don't when you're in a production environment, it takes a lot of time to manually change a tool. So you can set up the machine to do that. Now, we have ATCs in stock here in Connecticut. We will be selling them in the next few weeks. What we're waiting for right now is we're working on the macro for UCCNC so that we can basically run it, and it'll interpret the G code so that we can tell it what position the tools are in. So basically what happens is it's a unit that you attach to the bottom of our HF500 spindle, and it uses pneumatics to hold on to the tool holder. And on the back of the machine is a rack. And basically what you do is you take multiple tool holders and you load your end mills in them, and you put them on the holder. You'll go through a process to touch off each tool so that it knows exactly the Z height of every tool, because they're not going to be the same when you put them in. And that's what this macro is all about. So now when you design a program, say you're in VCarve Pro and you're doing a carving job, so you might have a rough cut end mill, say a 1/4 inch end mill, then you'll have an 1/8 inch ball nose for the carving. Maybe you're going to do V-carve letters, so you might have a 1/2 inch 90-degree V bit in there, and then perhaps you might have 16th inch ball nose for very fine detail work. So that one job could have 4 end mills. So that's 3 tool changes after you set up the first one on the job. You would load all those tools in the holders on the rack, and when you're in Vectric, you'll assign a tool number for every tool path that you're doing. So you're going to go in and it'll know, okay, we're going to do a V-carve letter. That's tool number 3. And when you create the output file, the G-code file for UCCNC, you're going to select the Mach 2/3 ATC metric output format. And what that's going to do is that's going to incorporate the tool number in the G-code so that UCCNC will recognize that, and it'll automatically pause the job, bring the spindle over, put the tool that's in the spindle on an empty holder on the rack, release it, then move over to the next tool it needs, and pneumatically it'll grab it, and then it'll go back and it'll continue the job on from there. So when you're doing multiple tool jobs, it really saves a lot of time. Not to mention it's pretty cool to watch it work too. It's, again, I've worked with large Haas type CNC machines. They're well over $100,000. And they have these, and it's cool to watch on a big machine, but to bring this technology and functionality to a small personal size machine is pretty cool. We expect the retail price to be about $599 for the ATC. So when you consider all the functionality it has, and depending on the type of work that you're doing with your machine, especially if you're making things that you're selling, time is money. It's not hard to justify the cost of the ATC. So I'll be talking more about that in upcoming episodes as we get the software finalized so that we can do it. It is working now with WinPCNC, but any customers that we have after April of 2015 that bought from Stepcraft USA has UCCNC and not WinPCNC. So we have to make sure that we have the macro specifically for that software. I will try to get a video link up. Germany had sent me a video of it working on the WinPCNC over there. And like I said, we have them in stock. But before we start selling them, I just want to make sure we're all set with support and software and everything. So in the next couple of weeks, we'll have that taken care of. And we're pretty excited to be launching the tool changer. I think it's going to be a great hit, and it'll be yet another thing that makes Stepcraft stand out amongst the crowd of personal CNC machines. Okay, so that's it for this week. I want to thank you again for joining me for another episode of the UCreate podcast. For show notes on this episode, please feel free to go to ucreatepodcast.com/010. Also, I want to let you know, I just finished, and I think I mentioned this in the last podcast as well, I finished writing a book called Start a Business Using a Stepcraft All-in-One Creation System. And I do have it available on the website. It's a free download right now in an ebook format. And if you would like to download a copy, please go to stepcraft.us/ebook. And you could put your name and email in, and it'll send you a link to download a copy of it. So for those of you who are looking to sell items that you make, or start a small part-time business, or even a larger full-time business, hopefully this book has a lot of ideas for you and kind of walks you through the process. So I would love to hear your feedback on it as well. So if you have any questions, or you want to be a guest on the podcast, or you have some questions you would like me to address, please feel free to email me at info@stepcraft.us. And that's it for this week. Have a great week. I look forward to serving you next week.